Welcome to IB Maths Made Easy. This is chapter 11, sampling and data. In this video we'll be covering errors in sampling, sampling methods, the types of data, discrete, simple and grouped discrete data, and then continuous data, and that will be the video. So there are four main types of errors in sampling. So we've got sampling errors, measurement errors, coverage errors, and non-response errors. So a sampling error is when the sample that you've taken is different from the entire population, or what you'd get from a census. And it's sort of a random error, so you can't really control it. It will happen anyway. A measurement error is an error in the method of measurement. So maybe you can only collect a person's height to the nearest centimeter. So the actual value that you get is different from the recorded value is different from the actual value. But it can also be from the ways that you ask questions. So asking a question in a way that would get to a specific answer, that would also be a measurement error. Then we have coverage errors, which is when the sample doesn't reflect the entire population. So it's similar to a sampling error, but it's slightly different because a coverage error is like you only ask one neighborhood if they like their city, or you only ask, just it's the specific way that you're asking. And then a non-response error is just when you don't get a response. So maybe it's a customer satisfaction survey. Many people are not likely to respond. The only people that will respond are those who either really like the customer service or really dislike it. So that would be a non-response error. And that's sampling errors for you. That's the four main types of sampling. So now onto the methods of sampling. There are 5 main methods that you need to know. So let's just walk through them. Simple random sampling. That's basically just grabbing, say if you need 3 people, you just grab 3 random people. Maybe you grab their names out of a hat or something. That's just simple random sampling. So each person has got the same chance of being selected. Then we've got systematic sampling. So you ask maybe like every 10th person of a population. So there's 100 people, you take the 10th, 20th, 30th, etc. And so that's systematic sampling. Then convenience sampling is just taking whoever's easiest and most likely to respond. So say you're collecting data in a shopping centre and people are walking past and you're asking them to answer your survey. You're not going to ask people who are on a different floor. You're not going to ask them to respond to the survey. You're going to ask people who are walking close to you, not on their phone, looking at you. So that's convenience sampling. And then stratified and quota sampling are quite similar, but they have one key difference. So stratified, the best example for this is you're in secondary school. You've got year 7, 8, 9, 10, 11, 12, all of that. So you'd say you want to take a specific amount of people from each year group. So you take, if there's the most year 8 students, then you'd take 5 year 8s. And then if there's only a few year 7 students, you take 2 year 7s. And then, etc. So you'd get each amount of different students according to how many of those students there are. And then with stratified sampling, you just randomly select those people from those year groups. So you'd randomly select 5 year 8s or something like that. But then with quota sampling, then you'd specifically choose the people. So that's the only difference. Stratified is, although they subdivide it into the categories, the actual people who are selected are random, but in quota sampling, the people selected are chosen specifically by the sample makers. A good example of the difference between stratified and quota sampling and how you'd actually do it is in this question. So say a sports club has got 80 tennis members, 60 bowling members, and 20 golf members, so 160 members in total, and they want to take a sample on the food or something like that. So they want to take a 40-person sample. So for both stratified and quota sampling, you need to take the right amount of people from each group. So you need to take the right amount of people from tennis, from bowling, and from golf. And the way we do this is actually to find the correct proportion of people. We do, so there's 160 in total, so we do 80 over 160 times 40. And that's how many people they'd ask from tennis. And then we do the same, so 60 over 160, 60 over 160 times 40, and that would get how many people you ask from the bowling section, and then 20 over 160, because this way you're getting the right amount of people from each section of the sports club, so it will be the best way you can do it, sort of. And then the way you do maybe sort of a simple random sample in this situation would just be, taking 40 names out of a hat and asking them. Convenient sampling, maybe you ask the people who are in the restaurant at one time. And then systematic sampling would be looking through the member list and picking every fifth person, something like that. So those are the different types of sampling for you. Now on to the different types of data. So there's two sort of main types. We've got categorical and numerical. And these two types, they are what they're called. So categorical is different categories, so maybe different colours, yellow, red, blue, that's categorical data. And then numerical, which are numbers, so 7, 4.32, whatever. But then in numerical, there's two types of numerical data, discrete and continuous. And these two are the ones you really need to know, because oftentimes or sometimes they'll have questions saying state whether this data is discrete or continuous. And the difference between them is discrete is just whole numbers, so 1, 7, 10, whereas continuous is not whole numbers, it's all numbers, so 1.33, 1.35, 2.00. And the difference is discrete is you get discrete data from counting. So you could say, like, how many steps did someone take to do this? So they take 40 steps. They can't take 40.3 steps. They take a whole number of steps. But continuous is from measuring. So how tall someone is, like 188.2 centimeters. That's continuous. So that's the difference. Discrete counting, continuous measuring. That's all you need to know. To display discrete data, we usually use a column chart. So you have the frequency on the y-axis and the number on the x-axis, so number of students, number of cars, whatever. And you can see here that there's gaps between the columns, and that's a key feature of the discrete data graph, because there's differences. It's counting, it's not continuous. Continuous is slightly different, similar but different, but just remember the gaps between the different pieces of data. And there are three main ways you can describe a data set. So looking at these graphs, this is how the sort of the trend line of the data would be. So if it just goes straight up and down in the middle, it's symmetric. But if the peak is towards the back of the data, you'd say it's negatively skewed. And if the peak is towards the start or the front of the data, it's positively skewed. So those are just two things to remember. With continuous data, you get a slightly different graph. It's similar, but it's slightly different. It's called a histogram or a frequency histogram. And the only difference is you can see there's no gaps between the columns or the bars. So each bar is connected to each other, and that's the main difference, because continuous is continuous, whereas discrete is counting, so there's gaps in between. And one other thing you should know is this notation. This notation is usually used if you see a table of continuous data. So that means 3 is, so x is smaller than 4, but it's bigger than or equal to 3. So on this little graph, we'd say this category, that bit here, is this bit here, this column. And then same with here, this one would be here, and this one would be here. So x is less than 6, but it's bigger than or equal to 5. So it includes this line and all of this. So that's just one of the things you should know. Thank you for watching. This has been IB Maths Made Easy. I hope this video helped, and make sure you come back and watch other ones. Thank you.